So what this is if you spot this specific situation, then you can solve it real quick. If you spot that the integral is set up, and so it's some compound function, one thing times another, but you notice the two functions. One of them is some function to the power of whatever, but then the other one is the derivative of that function. If you spot that, then you actually can just do add 1 to the power over the power. Okay? Again, it will save you a lot of time. The trick is spotting it. Now, this is a roundabout way of showing you why it works. Because what it is it's, you know how we saw the question in the textbook, which was the reverse of the product rule? This is kind of like the reverse of the chain rule. Find the derivative of the square root of 1 minus x cubed. Well, all right. We would anarchy, bring down the power, lower the power, diff the inside, and there it is, minus 3x squared on 2 root 1 minus x squared. Often you'll see a question like that followed up with that. Hence, go and find this. And so it's using the idea that, hey, I know that if I differentiate that, I get that. Therefore, if I integrate that, I should get the square root of 1 minus x cubed. Now have a look at it. Minus 3x squared on 2 root 1 minus x squared. What are they asking me to integrate? Not quite the same, but we certainly can make it the same. Remember what we just got was minus 3x squared on 2 root 1 minus x squared. But I am allowed to factorise constants. So if I put a minus 2/3 out the front and then factorise the minus 3 and the 2 out, I would end up with x squared on the square root of 1 minus x squared. So I just got to balance it out. And we know what that integral is because we just worked it out. It was the square root of 1 minus x cubed. That's the basic idea. Now, they led us to that idea by going differentiate this, hence that. We want to be able to spot it when they don't give us the hint. Something like that. So you look at it and you go, hang on. You always look at the function that's to the power. So 2 plus x squared is to the power of a half. And you say, well, what is the derivative of that? Well, it'd be 2x. Well, I haven't got 2x, I've got x. But I can make it 2x. So I'll make it 2x. I now have that situation. Derivative times some function to a power. So now I can just add 1 to the power over the power. So it'll be 3 on 2, but times 2/3. 2's cancel, we end up with mere mortal answer, 2 plus x squared, 3 on 2 there, but of course, super mathematicians, 2 plus x squared root 2 plus x squared. There is another technique which we will be looking at in more detail later, so don't panic, which is known as using substitution. Let's turn it into a different function. So I could have looked at this and said, what's causing me the problem? So the same question, well, 2 plus x squared is causing me the problem. So let's turn it into a new function. And my pronoun is going to be u, and it's going to equal the thing that's causing me the problem. U is equal to 2 plus x squared. Now, of course, if I differentiate that, I get 2x, and then I can sort of like multiply out and get the u is 2x dx. Reality is when I do these, I don't write that middle line, I just usually go straight to that one there. Or du will be 2x dx. Okay. I now have a key to substitute into the original question. But when you do this, you've got to change all the x's. You can't have some x's and some u's. It's a complete substitution. So when I look at it, I go, haha, there's 2 plus x squared. I can get rid of that bit. Well, hang on, x dx. That's a half of du. So I can now rewrite this as a very simple integral. A half times the integral of u to the power of half du. Add 1 to the power over the power. You will notice my line there is now pretty much the same as the second last line there. It's just that I've got u instead of 2 plus x squared. But hang on, we said u was 2 plus x squared. So now I can put the x's back in. And there's our answer. So that idea we will look at in more detail later. Let's do one more. Here's a definite integral. But it doesn't matter, it's still the same idea. What's causing me the problem there is that x cubed minus 2. What is the derivative of x cubed minus 2? Well, it's 3x squared. I haven't got 3x squared, I've got x squared. I can turn it into 3x squared. So let's do that. I now have derivative times some function to the power. And the power is negative 3, but we've got what we want. Beautiful. I can just add 1 to the power over the power. So that'll be minus 1/6 x cubed minus 2 to the negative 2, and I'm going to substitute in from 0 to 1. So subbing in, there's my answer, minus 1/8. If you did that one via the substitution method, what would I do? I'd say, hey, what's causing me the problem? Well, I'll make u equal to x cubed minus 2, so the u will be 3x squared dx. I need to get every occurrence of x out of there. There's actually 2 occurrences of x there that you don't notice. And that's 0 and 1, because they're both x values. I now need to turn them into u values. How do I do that? Well, u is x cubed minus 2. So when x is 0, u becomes negative 2. And when x is 1, u becomes negative 1. So we substitute every occurrence of x back in there. You don't do bits and pieces, everything goes in. There's our new integral. So you will notice the u to the negative 2, we had x cubed. But here's the thing, in this one, I don't have to substitute back in for x now because we're dealing with a definite integral. I can just sub in these ones we've worked out. So I go straight into that. And we get 1, well, obviously we get minus 1/8 again. Alrighty, that'll do it.